the range is the set of images, the set of all actual outputs. Okay, the codomain is set of possible output, and range is the set of actual outputs. We saw functions could be represented using by just listing the input output pairs, listing the image and pre-image pair. Pre-image and image pairs is a ordered pairs, or it could be drawn mapped, could be represented with a bipartite graph. Here on one side we draw the domain, and the other side we draw the codomain. If an element is mapped to another element of the codomain, we draw a line between them. Okay. We could also represent a function by a numerical formula, by some mapping rule, some algebraic expression that tells you how to map one thing or other. And we saw briefly, you can like the programming code function, the Java function, C++ functions are also exactly the same functions. The domain is what's called the parameter types, the argument type, and the codomains are the output types, the return types, and the functionality mapping rule is how it's given by the what's given the function body. Okay, so today we are going to talk about the types of function, right? So this you must have heard in your high schools. A function is called one-to-one, or an injective function, or an injection from the domain to codomain if the following is true. Okay. If for any two elements in the domain, whenever the images of x1 and x2 are equal, then the pre-images must also be equal. Okay. So it's this is a technically correct definition, but the way to think about this implication is I'm going to show you. For any pair of elements, whenever they map to the same elements, then they must be the same, right? So if the outputs are the same, the input must be the same. If this is true for any pair, that means the function is one-to-one. Okay. If you look at the contrapositive of this implication, the contrapositive says the following: for any pair of x1 and x2, x1, if x1 is not equal to x2, then f of x1 is not equal to f of x2, right? So for two different inputs, I will get two different outputs, right? So every input, every element of the domain gives a unique output. Every element has a unique image, different than all other elements in the domain. Okay, this function is called a one-to-one function, or it's called an injective function or an injection. Is this clear? So every element of x in the domain is mapped to a unique element of the codomain. Okay, so look at this function. This is a function. The 5 elements are the codomain. The 4 elements are 5 elements are a domain. The 4 elements A, B, C, F are the codomain. The mapping is given by these lines. Is this a one-to-one function? Why is this not a one-to-one function? Sorry? X3, sorry, X3 and what? X4 have the same image, right? So X3 is not equal to X4, yet f of X3 is equal to f of X4, right? X1 and X3 and X4 are not mapped to unique images, right? They have the shared image, and that's why this is not a one-to-one function, right? Also X2 and X5 are both mapped to A. They are different elements, they are different inputs, output is the same. That's why it's not a one-to-one function. Okay. This function is again the domain now has 4 elements, the codomain has 4 elements, and the mapping is given. Is this one-to-one? Right? For all pairs of elements, there are many pairs of elements here: x1, x2, x1, x3, x1, x4, x2, x3, x2, x4, x3, x4, right? And maybe other, if you think of, we don't consider ordered pairs, but there are many pairs you can make here, right? On this side, each pair you can check if they are for each pair, the output pair is also they're not unequal, right? The outputs are not equal. Okay. So this is a one-to-one function. How about this one? Is this a one-to-one function? Quickly, is this a one-to-one function? Yeah. Yes. All elements are mapped to, every element is mapped to a unique element in the codomain, right? So how about this one? If I have a function from integers to another integer, but now it's too long, a bigger function, the domain is an infinite set and the codomain is an infinite set, and the mapping is given by every element is mapped to its double, you double the element and then subtract 3 out of it, and that is going to be the output for each for a given x. Is this one-to-one? Yes. How do you know? What would it mean, or can you say this function being one-to-one in some different word? Can you just, in this specific context, can you say the one-to-one requirement? Yes, please.
As an inverse?
Generally speaking, that may be true, but we don't know. Inverse is not in our vocabulary yet. So, one-to-one, we have a condition, right? If x1 is not equal to x2, then f of x1 is not equal to f of x2. Any x1 and x2. You want to say this thing? Yes?
In linear graph, linear function, every element would have a unique value for x.
So, the requirement is, okay, let's just try different x1 and x2 just to convince ourselves. But if you really think about it, every number among the integer has a unique double, right? It's true. Every number has a unique double. Right? You just multiply it, you will get exactly one number. If you multiply two numbers, you double two numbers, you will get two different numbers, you will get two different doubles, right? And then you subtract 3 from it, is just shifting the double, you double it and then you reduce it a little bit. But we have a definition. The definition says, and that's why the reason of this thing is not just the example. I gave you the more difficult definition here. That if the output is the same, then the input is the same, right? It really is with the same statement as if the input is different, the contrapositive, then the output is different, right? But this is very easy to see this thing, when you actually want to prove that a function is one-to-one, you will use this definition, right? This is easier to do this thing. If two different numbers, their double will be different. That's intuitively true, but it's hard to argue it like more technically, right? But look at this thing. Suppose I have two x1 and x2, some numbers x1 and x2, not necessarily unequal, no condition there. Suppose f of x1 is equal to f of x2, right? Suppose the output on x1 and x2 are equal. That means twice x1 minus 3 is equal to twice x2 minus 3, right? That's the definition of f. I just substituted the value of f there, right? On the input x1. So, that means 2x1 minus 3 is equal to 2x2 minus 3. Now, the 3 appears on both sides, I can cancel it, I get 2x1 equals 2x2, right? When 2x1 is equal to 2x2, that's when we said, okay, the doubles of every number is different. If 2x1 is equal to 2x2, then that means x1 is equal to x2, right? So, if f of x1 is equal to f of x2, then x1 is equal to x2. Right, and that's the definition of function being one-to-one. That's for any pairs of numbers, any pairs of element, integers in this case, x1 and x2. This is true. Okay, if their output is the same, then the input must be the same. This function is one-to-one. Okay, let's do quickly these functions. Suppose the function is from integers to reals, and the function is given, the mapping is given as f of x equals x squared. You give it an integer, it will return the floating point of the real, the square, right? So, essentially, you will just add 0.0 to it. Is this one-to-one? Why not? Sorry? Now, one-to-one requirement is a existent universal quantifier statement, right? For all x1, x2, if f of x1 is not equal to x2, then f of x1 is not equal to f of x2. So, now you have to give me, if you say it's not true, you have to give me, yes please, let's say they raised hand. 1 and negative 1 are two different numbers, x1 is not equal to, let x1 be 1 and x2 be negative 1. x1 is not equal to x2. What is f of x1? What is f of negative 1? The square of negative 1 is 1. And what is f of 1? Square of 1 is also 1. We got two different numbers, x1 and x2 different, but f of x1 is equal to f of x2, right? Not different. Hence, this function is not one-to-one. Okay? Okay, here's another function from real to real, f of x equals x cubed. It takes a real number, return the cube of it. Is this one to one? Why? This function is one to one. Sorry? Yes. Function is always increasing. Big words, difficult words. That's true. The function is increasing. How about it's increasing? X cube is increasing. What's the negative numbers?
They translate to negative.
Yeah, but that's still increasing. Okay. Yeah, we'll see, but that's not in our vocabulary yet. Some other way. Just say this word. This function is f of x equals x cubed. Can you say this in English? What does it mean when I say this f is 1 to 1?
Multiplied by itself 3 times.
That's the definition of x cubed. I've said the function is 1 to 1. You have to translate that statement.
The cube of every number is unique.
Yeah, every number has a unique cube. That's a better translation of saying that this function is 1 to 1. Yes, please. That's a good thing. We saw an example earlier for 2x minus 3. We proved that that was going to be, that is 1 to 1. In the way we proved it, we just applied the definition, right? So here also we'll apply the definition. We'll say, let's say f of x1 cubed is equal to, f of x1 is equal to f of x2, where x1 and x2 are some number, right? Also, okay. What is f of x1? x1 cubed. What is f of x2? x2 cubed. If x1 cubed is equal to x2 cubed, then this is equality. Take the cube root of both sides, you get that x1 is equal to x2. So whenever f of x1 is equal to f of x2, that implies that x1 is also equal to x2, and that is the definition of one-to-one function. Okay. Okay. A function mapping integers to other integers, and a function mapping integers to their doubles. What would be, is this 1 to 1? Yeah, this is, we talked about it earlier in 2x minus 3 and in general double context. If 2x1 is equal to 2x2, then x1 is equal to x2. Hence, this function is 1 to 1, right? A function of mapping integers to natural number, where each number gets the value is equal to the absolute value. Is this 1 to 1? No. So for all x1, x2, f of x1 equal to f of x2 implies x1 equal to x2 is not true. That's what you are saying when you say this function is not true, right? So why is it not true? Why is this not true? Or what will it take to convince me that this is not true? Yes, please. So let's take f, apply f to 1 and apply f to negative 1. What is f of 1? 1. The absolute value of 1 is 1. What is f of negative 1? The absolute value of negative 1 is 1. Now I got two numbers x1 and x2 which are unequal. 1 is not equal to negative 1. Yet f of x1 is equal to f of x2. Thus this function is not 1 to 1. Okay. Here is a function. Suppose I have some kind of set of people, maybe set of people alive now, or set of people, like the union of the population of the world, right? The whole world population. And function is defined as f of x is equal to the father of x, right? You give it a name of a person, it will return the name of the father of the person, right? The biological father of a person. Is this 1 to 1? What would it mean to be 1 to 1?
That would mean everyone has just one child.
Yeah, in a world where everybody has one child exactly and one child alive or some kind of it, right? So this function, generally speaking, again these are just, I give you this thing so that you come out of this algebra a little bit, just to see, so that you are able to pronounce it properly in your own word. This, well, if I give two siblings and I ask their father names, they should be the same if they are like full siblings. Then their father name is the same, and it's not true that every input, for every pair of different input, I get a different answer. Yes, please. Yeah, didn't you raise hand? Okay. So f of, is it true? Is it clear, right?
Not one.
Sorry, it's not one to one. Yes. Yeah, it's not one to one. I don't know, false or true. It's not one to one, right? I wanted you to understand which functions, how to check or to see if a function is one to one or not, right? You answer whatever you want to answer. Okay, a function f is called, second property, second type of function. A function f is called a surjection or a onto function or a surjective function if for every element in the codomain there is some element in the domain whose image is this element y. Okay? For any y in the codomain, there is some element in the domain whose image is equal to this y. If you remember, I told you, think of functions is suppose all hostelite student, that's a domain, LUMS, all LUMS hostel rooms, allotable rooms, just usable rooms in LUMS hostels is the codomain, right? And think of this allotment, hostel allotment is a function. What would it mean for the hostel allotment to be one to one? Yes.
There are no two people with the same room, no room.
Yeah, so the answer is there are no two people with the same room. Can somebody else say an even simpler word?
Every person gets one.
Every person gets one room. That's a function requirement, right? If somebody gets two rooms, it's not even a function.
One room will house one person.
One room will house one person. Rough, not totally true, but somewhat correct. Every person gets a unique room. Yes, something correct, but I really want more colloquial. How do you say this? Yeah. Every room will have one person. How do you get this? How do you get this? From here. Every room will have one person. Yes. Yes. I just want you to come out of this technical terminology and just tell you. That's why I'm using this. No one has a roommate. That's better. So every person, every room gets one person is not totally correct. If you say every room gets at most one person, that's correct, right? Every person gets one person, meaning no room is empty. This says nobody shares a room. That's a even thing. No pair, no two people share a room. That's a good way of saying the function is one to one. The hostel allotment is one to one. Okay. So a function is onto if for every element in the codomain, for every y in the codomain, there is some x such that f of x equals y. Okay. Every element y is assigned, every element of the codomain y is assigned to something. It is the image of something, right? So for all y, that's how we will write it more precisely. For all y in the codomain, there exists some x in the domain such that f of x equals y, right? This small y. Yeah. Can you say this thing in the hostel allotment analogy? Just very non-technical description of this thing. Yes. No room is empty. Yes, or all rooms are allotted, or
Every room is assigned one.
every room has at least one occupant, right? At least one occupant. Remember that it says there exists, right? There could be more than one. Here is a more technical way of saying it. What is range? The set of actual outputs, the set of actual images. Codomain is the set of possible images, right? For the possible outputs. This one says every y is actually the output of some input. So this means the range is actually the codomain. Every possible allottable room has indeed been allotted, then the function is onto, right? So the range is equal to the codomain. Is this function onto? Quickly, yes or no? Why yes, why not? Please, you guys say something. This row and this I'll just say is empty. Is this function onto? Yes or no? Why? What is the values of y's? Yeah, it's not y, okay? Just please say it's a codomain. If this may be set y, the set b, the set x, right? That the x, y are not fixed. If every element in the codomain, in pictorially, what does the requirement of onto functions is?
The range equal to codomain. Range should be equal to codomain.
No, pictorially, in picture, range is in picture. What does it mean? Yes.
Should be an arrow to each element in the codomain.
There is an incoming arrow to every element in the codomain. That's a good answer and actually correct answer, right? How would you pictorially describe a function to be one-to-one? A function to be one-to-one, how would you pictorially describe? In terms of these lines and arrows or something. Yes, please. Every element has at most one incoming arrow, not exactly one, at most one. This one says at least one. Yes.
Sir, at least one element in the codomain should have one incoming arrow.
Every element should have at least one incoming arrow.
Isn't that the definition for onto function?
Yes.
But for one-to-one, it should be same.
For one-to-one,
Ek element पे आ जाए.
at most, no, every element can get at most one incoming arrow. No element can have more than two incoming arrows. Yes.
Every element in the domain has exactly one output.
That's a function definition. This has nothing to do. No, if there are ever two outgoing arrow, it's not a function. In the domain, yes, in the domain, whenever if there is two outgoing arrows, that means f of x5 is both a and c, and that's not a function. Okay. Again, these are just definition, rephrasing it, just whatever way it's convenient, understand it, okay? Totally understand it in all different ways, whatever analogy you make up, do not make these mistakes, okay? Okay, so this function is onto. Is this function onto? Yes, why? Because A, B, C, F, everybody has at least one incoming arrow, right? This one is onto. B has two incoming arrow. That's not, it's not one-to-one. B having two incoming arrow mean f of x3 is equal to f of x4. It's not one-to-one, but it is onto. This function is both one-to-one and onto, right? How about this one? This one is it onto or not? Why not?
Because F does not have any pre-image.
Yeah, F does not have any pre-image. That's a very good way to put it. F, this one element in the codomain who is not assigned to anything, does not have a pre-image, right? What is the range of this function? The set A, B, C and D. What's the codomain of this function? The set A, B, C, D and F. Range is not equal to codomain, right? In the previous two, the range and codomain were equal. This is not onto. Okay, let's go. F of x equals x squared. Integers to reals. Is this onto? What would it mean for this function to be onto? Just please, so let's wait. It's you guys, if you're not talking to me, I'm going to ask you a question. What does it mean for this function to be onto? Yeah, that's the definition in this terminology, in x squared, like more non-technical, not, yes, somebody else. One next to you, which you are not speaking, is you. Okay, that's true, but in this context, in this terminology, in more algebraic terminology, what would it mean? Yes?
Every real number is a perfect square.
Every real number is a perfect square. That's a good way of saying it. If this function was to be if I want to say this function is onto, basically I am saying every real number is a perfect square. Perfect square means square of integers, right? So for every real number is the square of some integer, right? Or every real number has a square root, has an integral square root. That is what this function is saying. Is this true? No. Is this function onto? Yes, please. Yes. So is this function onto? No, right? Why? Why is this function not onto? You give me one example. तो -1 का क्या हुआ? Okay, yes, so minus pre-image, what does it mean pre-image?
Like there is no element is where we have to back at minus.
Yeah, so there is no number, there is no integer whose square is equal to -1. That's what you want to say, right? There is no number, no integer whose square is equal to -1. But it's also true there is no integer whose square is equal to 17.4. Right? Is there any integer whose square is equal to 17.4? So not just negative numbers, okay, it's all non-integral, non-perfect square real numbers have this thing. There is no integer whose square is equal to 1.07.
Or just 2.
Yeah, 2 is also, there is no integer whose square is equal to 2. Yes, so pay attention to the domain and codomain. Okay, domain and codomain. Last time I told you these things will change everything. Okay, domain and codomain changes everything because that's the integral part of the definition. Last time I told you function, let's say a hostel allotment function, then we said, okay, what if some student of Punjab University is given a room? Right, that's not a function, that's not allotment. The domain is hostelite student in LUMS or LUMS students, right? What if some LUMS hostelite student is given a room in Islamabad, right? That's not a thing. The codomain has to be rooms in LUMS, right? A lot, and those kind of things. You pay attention to this. Here, every real number has a square root, actually 2, right? But the problem is every non-zero real number has a every non-negative real number have 2 square roots, but this says the square root must be an integer. If this function is going to give me, then it must be an integer because the domain here is integers. So this is not onto. Yes, you wanted to say something?
तो जो हमारा domain है वो तो set of integers है ना?
Yeah, integers. Yes.
Set of integers के पास तो x square हमेशा perfect square है.
Yes, so but the onto requirement is going to be kind of occupying all these rooms, right? It's in this codomain is every room occupied.
जो हम set of real number से कोई counter example लेंगे वो तो set of integers में होगी.
तो नहीं होगी ना, तो हमें real का example लेना है. Is I gave you the example that we get. So if this function was onto, that would basically mean that every real number has an integral square root. That is actually the statement. This function is onto. In this terminology, for this f means every real number has an integral square root. Okay, that's what she said. Every real number is a perfect square, but that's not true, right? So onto requirement is not fulfilled here. So next question: function from real to real f of x equals x cubed. Is this onto? What would it mean for this to be onto? Can you pronounce the statement? This function is onto. This function from real to real is onto. What does it mean? You guys just please say something. No, not last rows. Or you that left side row. No? What does it mean for this function to be onto? Every real number has a unique cube root. Why unique cube root?
So there is at least one cube root that every real number.
Yeah, but uniqueness in at least one is not the same, right? They are not the same. That's a different thing. Now I'm saying when I say this function is onto, just rephrase this statement.
Every cube root has
Real
real number has at least one cube root.
has a real cube root. Yes. Okay. Every real number has at least one real cube root. Okay. You can say it about square root also. Every real number has a square root, right? But not necessarily real, right? We can define some imaginary complex number to be square root and -1's, what is it called, iota or something. You can do that, but among reals, right? So that's what it means for this function. Is it true? Is this function onto? Every real number indeed has a real cube root, right? At least one real cube root, actually exactly one real cube root. Okay, f of x from integers to integer, f of x is 2x. Is this onto? Can somebody say what does it mean for this function to be onto? Let me just I want to listen to hear from those people. This last row, can you, the green shirt, can you tell me? Yes. What does it mean for this function to be onto? It may or may not be onto. I'm just saying, just say the words, this function is onto, just translate it. So not so technical, no, just come up with more colloquial type of translation.
Every value in the domain points to a specific value.
Domain and codomain, so we have just got rid of this. Instead of domain now, there is an integer, now set of integers, so just say the words here. No, that's not a requirement of onto. Yes?
Every integer can be half to give another integer.
Every integer?
Can be half to give another integer.
To give another integer. Can you send somebody else say something? Yes?
Every integer can be.
Every integer is even. Actually, that's what it means. Every integer can be written as 2 times another integer. Every integer can be written as 2 times another integer. Every integer is the double of another integer. These are the translations, okay? These are a translation, no domain, codomain, mapping or anything. Every integer is the double of another integer. And that's another way of saying every integer is even. Okay, is this true? Is this function onto? No, right? It isn't onto because 3, let's look at 3. 3 is an integer. What is, for what x, f of x equals to 3? There is no integer such that 2 times that integer is equal to 3. 2 times any integer is going to give me an even number. 3 isn't an even number, right? Okay, function from z to n, n is a natural number and the mapping is the absolute value mapping. What is this function onto? Is this function onto? What would it mean for this function to be onto? Just say the function the way we have been saying this thing. What does it mean for this function to be onto? Yes? Yes?
Every natural number is an output of this function.
Every natural number?
Will be an output of this function.
Yeah, but say this. Yeah, every natural number is the absolute value of some integer. Is that true? Yes, every integer is the absolute value of itself and itself is also an integer, so that's why it is true, okay? Function from people to people, whatever definition of people you set, f of x is equal to father of x. What does it mean for this function to be onto? What does, it cannot have father or anything, it has to be these two things. Every element in the codomain, it has to begin from here, has something on the other side. Sorry? This function would be something, can you say when I say this function is onto? Every person has a child? Not really, so you have to substitute child for something. Every person is someone's father, right? That's not every person as a child would mean, so like it will include, it will just not incorporate this definition, right? Every person is a father of someone, that's what it means. Is this true? Yes?
That's why the question.
Sorry, yes, go ahead.
So if there is a function from a bigger set to a smaller set, so will it like be never one-to-one?
We'll see that thing. Right now, bigger and smaller is going to be, for in these sets, we don't even know which one is bigger, which one is smaller. But we'll come to that in 10 minutes. Good question. Everyone has a father is not a thing. That's not the meaning of onto. Everyone has a father is just this definition that this is a function. Every element in this, every person here must have an image here. every person here must have a father. That's just the fact that this is a function, right? Every element has exactly one image. Every element in the domain is mapped to every. Okay, that's the definition of function. The additional property that it is a function, but it's an onto function would mean that every person here is the father of someone here. Okay, is this true? Is it true? Why not? Why is this not true? Is everyone the father of someone? Why not? Give me a counter example. If this is not a, I made a universal quantified statement, you have to give me a counter example. Yes? He is not, and you are? Yeah, so you plug in any name of any woman, it's not. No woman is a father of someone, right? People to the set of fathers, we would have had to define this thing. Yes, if the set of people who actually have, a set of men who actually have some children, if that was a set, then this function would be onto. Not one to one, because again two siblings will have the same thing, but then you are excluding all the women from this side and you are excluding all the non-fathers from this side, right? All the non-parents men. Yes. Sorry? Can you please, you guys stop talking? Yes, please. Male people to male people hota, so then it will not be true. Then her example would work, because then anybody who is not married yet or who doesn't have a kids yet is not a father of anyone, right? Even if you restrict it to only males. Okay. Here is a function now, more example, f of x equals 2x minus 3. We saw this earlier. What would it mean for this function to be onto, and how to prove? Is this onto function? Onto means every element in this integer has a pre-image. There is another integer such that there is an integer for every y, there is an integer such that integer x such that y is equal to 2x minus 3. Okay, so is this what is the range? Yes. So how do you prove a function to be onto? It takes time, just like proving a function to be. Let's see, if this function was onto, so let's look at, suppose an element is in the range of this function. So just find those elements for whom there is a pre-image. Let's say, so y is an element, a generic element such that y has a pre-image, and let's say x is the pre-image of that. So y is equal to 2x minus 3. Okay, well, immediately you could see 2x minus 3 is even number, right? So y is equal to 2x minus 3. That means, just do something, y is equal to 2x minus 2 plus 1. 2x minus 2x minus 2 is an integer, right? So any y that is a range can be written as twice another integer plus 1. That's just another way of saying any y which is in the range, any y which is actually the image of something is odd number, right? So all images are odd numbers. What is the codomain of this? What is the range of this thing? What is the range of this function? Odd integers. What is the codomain of this function? Integer. So this is not an onto function. Okay, it isn't an onto function. No. So say everybody has a pre-image. What is the pre-image of an even number? Let's say, what is the pre-image of 4? There is no pre-image of 4, right? Nobody. 4 is not equal to 2 into x minus 3 for any x, any integer x. So this isn't onto. Okay, one more thing. A function is called a one-to-one correspondence or a bijective function or a bijection if that function is both onto and one-to-one. So a one-to-one function and an onto function, if a function has both of these property, then that function is called a bijective function or a one-to-one correspondence. Okay. So So what does the correspondence mean? What does one-to-one mean? Every element in the domain is mapped to a unique element. And what does the onto means? Every element in the codomain has been assigned to something. If you combine both of them, it basically says that, you think about it, if I tell you hostel allotment, everybody got a different room, a unique room, right? Nobody is a roommate of anyone else. Nobody shares a room. Everybody got a room, that's a function. Nobody shares a room. No room is empty. What does it mean? If there are 100 students and they got an allotment as a function, right? Nobody sleeps in the room on the street. Nobody is given a room in Gulberg, right? Everybody is, every exact mapping is a function. And now I tell you, none of these 100 people, no pair of these 100 people share a room. No two are roommates. And I also tell you, no room is empty. Well, how many rooms must be there? How many rooms must be there? Can there be 101 rooms? Why not? If there is 101 room, what will be wrong? Yeah, but I told you no room is empty. And still I am saying no room is empty and there are 101 rooms. What's wrong with this statement? Then somebody got 2 rooms and it's not a function, right? Can there be 99 rooms? 100 people allotted as a function, no one shares a room, no room is empty. Can there be 99 rooms? Why not? Yeah, if there is 99 room, here is another way to put it. There are 99 rooms, nobody shares a room. There are 100 people. Somebody got a room outside the codomain. Right? There is 99 room, 100 people got a room, nobody sharing. That's not a function. Element has to be mapped to the codomain. You can't just give a person a room in Batachok, right? It has to be a room in hostel, in these hostels. So that's what it means. This is perhaps given somebody asked the question here, right? Somebody asked this question, I told you we'll come to that. If the function is one-to-one and onto, meaning the function is a one-to-one correspondence or a bijection, then the cardinality of the domain must be equal to the cardinality of the codomain, right? You asked a question? So then you say this, no, 3 times I repeat. Okay, so the cardinality of the domain must be equal to cardinality of the codomain, and that's why we'll see when we do counting and combinatorics, there is a thing called bijective counting, this combinatorial proofs of counting. You will see that, that's exactly this thing, okay? We'll establish. Okay, is this a bijection? Is this a one-to-one correspondence? Why not? What is a bijection? Which functions are a bijection? What does it mean for a function f to be a bijection? Quickly. Say it louder. No, the one in front of you. One-to-one be? So a function is bijection if it is both one-to-one and onto. Is this function a bijection? Why not? Yeah, but that's what you didn't tell me about x3, x4. You gave me a definition of a bijection. Now I'm asking you, is this a bijection? Why not? It's not a one-to-one function, right? It's not a one-to-one because f of x3 equals f of x4. So you're right, but just make your life easier, okay? This function is not a bijection because it's not one-to-one, even though it's an onto function, okay? One requirement isn't met. Is this function a bijection? Why not? It's not one-to-one, it's neither onto, right? But this is not a bijection, right? Both conditions are not met. Is this function a bijection? Because this is both one-to-one and onto, right? This is no incoming arrows, exactly one incoming, at least one incoming arrows, no more than one incoming arrows. So at most one incoming arrow and at least one incoming arrow. That's it. At most one incoming arrow is 1 to 1 for a codomain, and at least one incoming arrow is onto. If you put in at least and at most together, greater than equal to 1 and less than equal to 1, you get equal to 1, right? From here, exactly one outgoing arrow is the definition of function, right? So that means the codomain is equal to the domain. Okay, is this function bijection? Is this function onto, 1 to 1 and onto? Why not? It's not onto. Why is it not onto? There is no image of f, right? Okay, then the same exercises that we did for the rest. So f of x is equal to x squared, the domain is integers, the codomain is real. Is this a bijection? Why is it not a bijection? It's not 1 to 1. Why is it not 1 to 1? Why is it not 1 to 1? Yeah, f of 1 is equal to f of negative 1, right? The square root of 1, and that's good. So it's not a 1 to 1, so it's not a bijection. Is this a bijection? F of x, same function which we saw earlier, f of r to r, a function from r to r, where f of x equals x cubed. Is this a bijection? Was this 1 to 1 when we checked it last time?
Yeah.
Was it onto? So this must be the 1 to 1 correspondence, right? It must be a bijection. How about this one? F of x equals 2x from integers to integer. Is this a bijection? So what happens? So what does it make? What property does it violate for the function? The function is not 1 to 1. Is it not 1 to 1? It's not onto. It is 1 to 1. Every integer has a unique double, right? That's true, but it's not onto. Not every integer is a double of someone. So it's not onto. That's why the function is not a bijection. Okay? Somebody wanted to say something? Yes, please.
So doesn't that same problem apply to 520?
Sorry, please.
Doesn't the same problem apply to 520 because not every real number is a cube?
Not every real number is a cube. It is. Every real number has a cube root. It's a cube of that cube root. 7 has a cube root of 7 is there. So just, I don't know, just do in your calculator this thing. That's an integer, right? That's a real number, right? Okay. You take 7 to the 1/3 power and you will get a number, and it's a cube of that number. Okay. F of x equals the absolute value of x, where x is from an integer and f of x is supposed to be a natural number. So what is it? Is it a bijection?
No.
Why not?
It's not 1 to 1.
It's not 1 to 1. Why? Nothing called modulus. Okay. Our last session on number theory and cryptography, we'll talk a lot about mod. There's nothing called modulus. Nothing called modulus in this world. It's the absolute value. Okay. Absolute value. Okay. F of people to people, is this a bijection? Why not? Is this a bijection? Why not? Why not 1 to 1? Why is this not 1 to 1? Why is this not 1 to 1?
Every child doesn't have the same heart. Sorry, every person doesn't have the same heart.
The same? What do you mean the same? Same as who? Yes. Yes. Two siblings could have the same father name, and that means it's not 1 to 1. Is this onto?
No.
It's not even onto, right? Women are not father of someone, fathers of someone. So that's okay. That's again the same example repeated. F of x equals 2x minus 3 from real to real. Is this a bijection? Is this a bijection? Why is not? Was it 1 to 1? Was it? Is it onto? It's not onto, right? Is it not onto? Is it onto? Yeah, okay. Can two number under this function, can two real numbers have the same image? How would you prove it? So let's suppose f of x1 is equal to f of x2, and that would mean that 2x1 minus 3 is equal to 2x2 minus 3. Did we do it? I think we did it earlier. And that if f of x1 is equal to f of x2, that means x1 is equal to f x2. Hence, this function is 1 to 1. Okay? And this function is onto because for any number, for any real number, for any real number y, if you think is what is f of y plus 3 divided by 2? Y plus 3 whole divided by 2 will give you, if you apply f to y plus 3 divided by 2, it will give you y, right? It's just simple thing. So, what do you call it? So, I want y to be equal to 2x plus 3. You solve for x, you get x to be what? Oh, it's minus 3, idiots.
What about all irrational values in the codomain?
Any real number y, if you take any real number y, the codomain is R, that could be rational or irrational, even though we don't know much of that. Take any real number, I want it to, can it be written as something 2 times some x minus 3, and I said yes, you can write it, just apply. So now do it. What is f of y plus 3 over 2? What is f of y plus, is y plus 3 over 2 a real number? What is f of y plus 3 over 2? Well, it says multiply this with 2 and then minus 3. So, what is this? Y plus 3 minus 3, which is equal to y. You see, so f of this thing will give me y. For this input, I will get the output y, and that's true for any number y. Okay, so this function is onto and 1 to 1. Hence, this is a bijection. Okay, this is a thing that I discussed earlier. We have a whole section on cardinality of infinite sets and Cantor's theorem, diagonalization, a lot of stuff there. Very beautiful stuff. Is going to be this is going to be the basis of that. I gave you some kind of ideas how to prove it. That 100 people going to 99 rooms, 100 people going to a certain number of rooms. If nobody shares a room, how many rooms must be there? If no room is empty, how many rooms should be there? Right? So those things. If there is a bijection between x and y, then the cardinalities are equal. If f is 1 to 1, what can we conclude? Which cardinality should be bigger, which should be smaller? Suppose 100 students went to 100 students were allotted hostels, and no two share a room. 100 students were allotted, no two share a room. How many rooms must be there?
Number of students is less than or equal to.
I give you 100 students were allotted rooms, no two share a room. How many rooms must be there?
Sir, the number of rooms can be greater than or equal to 100?
At least 100, right? How many rooms? 100 people got a room, no two share a room. That's so when a function is onto, we would say that the cardinality of y must be greater than or equal to the cardinality of x. If you have fewer rooms, more students, some people must be sharing a room. Some pair must be sharing a room. What can we say when a function from x to y is onto? What should be the cardinality of this? 100 people got rooms, allotted rooms, no room is empty. How many rooms must be there?
At least if any students.
Cardinality of y is less than equal to cardinality of x.
Less than or equal to 100. There could be 99 rooms, there could be 98 rooms, it could be one room if you just bundle all of these 100 idiots into one room. That could happen, but it cannot happen that there are 102 rooms. Why? Because then somebody will get multiple rooms. Okay. So this was a summary of this thing.